Last time we looked at what a function is. We remember one input maps to one output, and we looked at mapping diagrams. But now we're going to look at a few other ways to represent functions. So we can do this with rules, and rules are equations, but you can write equations or you can write them in words. So it says write a function for a rule. The output is 5 less than the input. So the first thing we do is we realize the output is what we get out, and that's our y, and our input is what we put in, and that's our x. So we assigned y and x for our variables, and it says the output is, remember is means equals, so I have y equals 5 less than the input. Well, if it's the input and it's 5 less than the input, then I take the input, take away 5, right? So here is a rule for my function. Write a function rule for the output is 5 less than the input, right? There it is in words. Here it is as an equation. So an equation can represent a function. Write a function for the rule. The output is the square of the input. Okay, that's interesting. But again, output is y, input is x. So the output is y is means equals the square of the input. The input squared, right? That's with the power there. And remember, squaring means multiply it by itself. So here's two different functions, two different rules. They take an input x and give us an output y. If I put in 2 for x into this equation, then I would get out 2 minus 5. That would give me negative 3. If I put 2 into this equation, I would get out 2 squared, which is 4. So you can use your function rule to figure out what your output is for a given input. We're not limited to just equations, though, and words. We can also use equations and tables. It says, what is the value of y equals 2x plus 5 when x equals 3? So we have our input, which is x. We have our equation, which is our rule, which says y equals 2x plus 5. And then we have our output, which is what we get when we solve our equation, which is y. So if I put x is 3, then I have y equals 2 times what x is 3 now, plus 5, which is 6 plus 5, which is 11. And so I would have an ordered pair, 3, 11, but I also know my output. So I could actually start keeping track of this in a table of x values and y values. When x is 3, y is 11. If I put in 4 for x, then I would have y equals 2 times 4 plus 5, which is 8 plus 5, which is 13, right? And so I could have this whole table of values. So I can use equations to generate tables, and this table is also a representation of a function. And remember, it's sort of like a mapping diagram. I have 3 maps to 11. I have 4 maps to 13, which means it's also a bunch of ordered pairs, x comma y, 3 comma 11, 4 comma 13. So we can use ordered pairs to represent inputs and outputs. We can use a mapping diagram to represent inputs and outputs. We can use a table to represent inputs and outputs. And we have this equation that tells us what output we'll have for a given input. All of these can be used to represent functions. And of course, if we have ordered pairs, then we also have graphs. So it says graph the function y equals negative 2x plus 1 using the inputs of negative 1, 0, 1, and 2. Well, I'm going to set up my table just like I had before. I'm going to have my input. I'm going to have my rule. I'm going to have my output. And so my first input is negative 1. My next input is 0. My third input is 1, and my last input is 2. So input, rule, output, negative 1, 0, 1, 2. And my rule says negative 2x plus 1. Negative 2x plus 1. So I'm going to go ahead and show this. So I have negative 2, and then instead of x, I put in my input. My input is negative 1. Plus 1. Well, now I solve this. Negative 2 times negative 1 is 2, and 2 plus 1 is 3. And then I do the same thing. Negative 2 but x this time is 0 times 0 plus 1. Well, 2 times 0, or negative 2 times 0 is 0, plus 1 is 1. And then I have negative 2 times 1 plus 1. Well, negative 2 times 1 is negative 2, plus 1 is negative 1. And then I have negative 2, and my input this time is 2, plus 1. This is, of course, negative 4 plus 1, which is negative 3. So I have my inputs and outputs. And then it says to graph that. Well, I can do all that. Let's see. Let's sketch some graph axes here. Remember, the x-axis is the horizontal axis and the y-axis is the vertical axis. And now I have a whole bunch of ordered pairs. I have the pair negative 1, 3. I have the ordered pair 0, 1. I have the ordered pair 1, negative 1. And I have the ordered pair 2, negative 3. And 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, negative 4, negative 3, negative 2, negative 1, negative 1, negative 2, negative 3, and 1, 2, 3, 4. So let's see if we can plot these points. Negative 1, 3 means go left 1 and up 3. So there's our first point. 0 over, 1 up, there's our next point. 1 over, negative 1 down, here's our next point right here. And then our last point, 2 over, negative 3 is right here. And it didn't tell me to sketch the line. It said graph the function, but I graphed it with those points. And so now if I draw my line through those points, I can actually see that this is a linear equation, which we already knew. And if you had skipped to, oh, well, let's just graph this line because I know the slope is negative 2 and its y-intercept is 1. So up here at 1, it crosses the line, and then it's going to go down 2 over 1, and you just graph this line. I couldn't argue with that because it is okay to use slope-intercept form to graph that line. Now, one more thing here. Sometimes we refer to the input and output as independent and dependent variables. Now, the input we get to pick. Doesn't depend on anything else. We're just like, oh, let's let our input be whatever. And so we choose it. It doesn't depend on anything else. However, whatever our output is going to be depends on what we chose for our input and the function rule. So here's an example problem. The number of pounds of carbon dioxide produced by a car is 20 times the number of gallons of gasoline used by the cars. Write and graph a function that describes the relationship between G and P. Well, it says the pounds of carbon dioxide produced by a car is. So that is P is, because is means equals, 20 times the number of gallons of gasoline, G. P is 20 times G. Okay? That's what that said in words. Is equals gallons G, and it's 20 times that. So P equals 20G, which means the pounds of carbon dioxide depends on how much gas is burned. So pound CO2, which is our output, depends, therefore we call it dependent, depends on the gallons of gas, which is our input. Right? So if we burn 5 gallons of gas, we would get out 100 pounds of carbon dioxide. And if you were going to graph this, because this is in a y equals mx plus b equation, the b is just 0. This would, of course, be a graph that goes to the origin, 0, 0, and has a slope of positive 20. This is pounds over here and gallons over here. Even though we're used to calling this y and x, we do know that this is the independent over here and the dependent over here.